Hello everyone. I hope you all are good and you all are practicing problems and learning concepts. In this video, we are going to do one question from Newton's law of cooling. And before we, start solving the question, first we will go through how we get the expression that we know for Newton's law of cooling and why it is important. क्योंकि देखो basic term आप क्या लिखते हो Newton's law of cooling के लिए rate of fall of temperature. It is basically a law that has to do with cooling of objects. Done it? So rate of fall of temperature is directly proportional to temperature difference. Temperature of body minus temperature of surrounding. And if you remove here this proportionality thing, you will replace it by a constant, let's say K1. We can also write it in different way. We write it like minus dq by dt, rate of fall of energy, the rate at which energy is getting emitted out of that body. That is why it is cooling. So this is directly proportional to temperature difference again. And here proportionality constant become K2. Now it is very important that we know K1 is function of what, K2 is function of what, how this K1, K2 is different. And also final expression that we get, how we can use that easily to get the answers. Okay. So I will take you through that first. Suppose कर लो हमारे पास एक चाय की प्याली है और हमें ये पता करना है कि ये चाय सर्टेन टेम्परेचर से सर्टेन टेम्परेचर तक कितने टाइम में जाएगी. ठीक है. So basically we have to talk about in what time it will cool from one temperature to another. And before we start, getting expression for this one, we should first consider certain assumption that we take for Newton's law of cooling expression. ठीक है. और वो assumption क्या है, देखो सबसे पहला जो यहाँ पे heat transfer होगा, यानी कि जिस वजह से तुम्हारा ये body cool हो रहा है, that heat transfer has only to do with radiation. So radiation की वजह से ही heat का loss हो रहा है यहाँ पे, only we have to talk about that. And then we can, second assumption, temperature difference, that is delta T, has to be very small. Temperature difference between T and that of surrounding has to be very small. These two assumptions we take while reaching to the expression of Newton's law of cooling. अब देखो हमने बोला heat transfer सिर्फ radiation से होगा. Then you can write dq by dt. And since heat is getting lost, I will give you a negative sign. And this is equal to how much? This is equal to sigma EA T to the power 4 minus T naught to the power 4. So this T is what? This T is the temperature of this T, that is TEA, and this T naught is what? It is the temperature of the surrounding. So this is the net amount of heat loss that is happening. Okay, so this is this one. अब देखो यहाँ पे T क्या, T minus T naught क्या होगा? This is your delta T. So T को आप क्या लिख सकते हो? T को आप लिख सकते हो T naught plus delta T. So let us put it here. I will just roughly take you through this, not in detail. Steps में कहीं minus plus हो जाए तो please forgive me for that, because I will just take you through the process. ठीक है? Process में कोई मुश्किल नहीं होगा. Don't worry for that. Conceptually it won't be wrong. That is what I wanted to say. So sigma EA T का power 4. T का वैल्यू मैं क्या रखने के लिए बोल रही हूँ? T naught plus delta T आप रख लो. So this का 4 power, right? Minus T naught का 4. Again you take the sigma EA, T naught को आप common ले लो. So T naught 4 and this will become 1 plus delta T by T naught minus T naught का power 4 and this is to the power 4, right? So this is this one. Now if you write it sigma EA and we can use one expression 1 plus x to the power n ko we can write 1 plus nx if x is far less than 1. So here also it is 1 plus delta t by t, and we know that delta t by t naught, right? Delta t by t naught, yes, we know that delta t is far less than t naught. So in that case what we can do, this to the power 4 को हम क्या लिख सकते हैं? 1 plus 4 delta t by t naught. Let us write it here. So 1 plus 4 delta t by t naught, and then there was this term t naught. Okay, t naught का 4 था, ठीक है, minus of how much? T naught का 4. Now let us multiply it and let us see for the thing. So this is equal to T naught 4 plus 4 T naught Q delta T minus T naught ka 4. So this will get cancelled, and here you will be getting sigma A 4 T naught ka cube delta T. So this is equal to how much? Minus dq by dt. So rate of loss of energy is equal to, it is directly proportional to what? Delta T. एंड व्हाट इज द प्रोपोर्शनैलिटी कांस्टेंट? दिस इज योर K1 मैं लिख रही हूँ, दिस इज 4 सिग्मा EA T नॉट का पावर Q. So this is depending on what factors. You just need to count that in. So obviously sigma, this is a constant for all bodies. Emissivity, nature of the material. A, the surface which is exposed to the environment of that cup. Okay, so अगर कप की प्याली बड़ी हो, I mean उसका surface area ज़्यादा हो तो जल्दी ठंडी हो जाएगी, right? अगर तुम प्लेट में चाय को पीते हो, इन गुजरात people used to drink it that way, so वहाँ पे चाय जल्दी ठंडी हो जाती है, right? So that will depend on how much area of that tea is exposed to the environment and T naught, which is temperature of the environment. So in सारे factors पे K1 depend कर रहा है. Now let us talk about K2. So अभी देखो हमें क्या मिला, minus dq by dt is equal to K1 delta T. dq को क्या लिख सकते हो, इसको हम लिख सकते हैं if this T has m mass and specific heat capacity is S and its temperature is changing by dt, let's say, then you can write this thing as, I mean q को आप क्या लिख सकते हो, ms delta t, right? and dq by dt को क्या लिख सकते हो, this can be written as ms is constant d delta t by dt. Done it? So d delta t, this is basically dt, that is what I'm going to write. So the rate with which this change is changing, okay, so minus dt by this is dt is equal to k1 delta t. Done it? I hope you're getting the difference between this delta T and this dt. So this delta T is what? Temperature of T at any point of time. Let's say it is T1 and temperature of surrounding is T0. So this is T1 minus T0. And what is this dt? This is basically, let's say at T1 time its temperature is T1 and at T2 time its temperature is T2. Then dt is basically T1 minus T2. So it is this one. Okay, rate of fall of temperature of the T, and this delta T is basically that thing. Okay, समझ रहे हो? I hope it is clear. So this is basically, और इसको यहाँ पे ऐसे ना लिखकर क्योंकि this is causing confusion sort of. So let us write it ms, I mean dt ही लिख लो आप. So this will be basically dt by dt. I mean डेल्टा टी लिखने से भी कोई प्रॉब्लम नहीं है, बट दोनों वेरिएबल सेम जैसे दिख जा रहे थे, दैट इज व्हाई आई वाज डूइंग दैट चेंज. सो एक काम करते हैं, इसको आप डेल्टा थीटा लिख लो, ठीक है? अगेन क्यू जैसा दिख रहा है. ओके, लेट अस डू समथिंग. डेल्टा अल्फा लिख देती हूँ, कुछ भी टेम्परेचर से ही इंडिकेट करना है, थीटा ऐसे लिखती हूँ, ठीक है? एम एस डेल्टा थीटा, डन है. एंड एम एस डी डेल्टा थीटा बाई डी टी, बेसिकली दैट इज डी टी बाई this thing. Okay, I hope you have got it. So this is this one. अब देखो यहाँ पे अगर आप इसको okay, what I did here dq by dt. अच्छा, यहाँ पे हमें q की जगह क्या लिखना है, देखो directly I have put it here. Let us replace it. dq की जगह आप क्या लिखोगे? dq can be written as ms dt by dt. So minus ms dt by dt is equal to k1 delta t. So this will be I mean dt by dt minus is equal to k1 by ms delta t. So what is this? This is k2, right? So k2 में एक्स्ट्रा फैक्टर आ रहा है, मास भी काउंट हो रहा है और स्पेसिफिक हीट कैपेसिटी भी काउंट हो रहा है. डन है? So ये सारे k1 and k2 का फैक्टर्स है. Now finally if you have to solve for the things, I mean if final expression that we are getting minus dt by dt और यहाँ पे प्लस कर लो, this is equal to minus k delta t. If you have to use this expression, either you can do integration, जैसे यहाँ पे dt by delta t को आप क्या लिख सकते हो? Temperature at any point of time minus t naught, right? That is delta t. Integrate करो equal to minus k dt. This is this. Let's say temperature of the t is changing from T1 to T2 and then it is happening in t time, let's say. Then you will be putting here, I mean integration क्या आएगा? ln t minus t naught and then limit you will be putting from t1 to t2 and then minus kt, sort of you will be solving, you will be getting, right? This is what we do. But normal एक चीज आप कर सकते हो which is taking the average, उस हेल्प से भी आप कर सकते हो. जैसे यहाँ पे बस इस एक्सप्रेशन को आप याद रखो, ठीक है? So dt is what? dt is basically temperature change happening. So let's say हमारा चाय का कप है and it is changing its temperature from 45 to 40. in a time of T1. डन है, एंड सराउंडिंग टेम्परेचर इज लेट्स से 25. सो ये एक्सप्रेशन आप कैसे लिखोगे? दिस एक्सप्रेशन डी टी इज हाउ मच चेंज इन टेम्परेचर 45 माइनस 40, सो दिस इज इक्वल टू 5. एंड व्हाट विल बी डेल्टा टी? सो डेल्टा टी आप क्या लिखोगे? दिस इज टेम्परेचर डिफरेंस ऑफ टी विद द सराउंडिंग. अब टी का टेम्परेचर 2 है इस टाइम इंटरवल में 45 एंड 40. हाउ यू विल बी कैलकुलेटिंग डेल्टा टी? सो टेक द एवरेज ऑफ दिस टू टेम्परेचर्स. ओके, किसका किसका एवरेज लोगे? 45 एंड 25 का. सो इफ यू टेक एवरेज यू विल बी गेटिंग हाउ मच? 70, राइट? सो इट विल बिकम हाउ मच? This will be 35. So here you will be writing 35 minus T naught, that is 25. Put it here and then you just put the things. Okay, so dt5 time taken is T1 and this is equal to minus K delta T, that is 35 minus 25. This will be how much? Okay, this is 10, right? And this minus sign, क्योंकि यहाँ पे डेल्टा टी का मैंने मॉड्यूलस लिखा है, सॉरी डी टी का मॉड्यूलस लिखा है. अगर आप फाइनल टेम्परेचर देखो 40 है, 40 माइनस 45 करोगे तो -5 आएगा. ठीक है, सो अगर मैं कंप्लीटली लिखूं -5, माइनस माइनस विल गेट कैंसिल बेसिकली. सो अगर तुम्हें क्वेश्चन में ये दिया है कि 45 से 40 T1 टाइम में जाता है तो 30 से 35, सॉरी 35 से 30 कितने टाइम में जाएगा? अगेन यू कैन राइट दैट थिंग ओवर हियर, डिवाइड इट, गेट द आंसर, राइट? सो दिस इज द वे वी कैन डू. नाउ लेट अस कम टू द क्वेश्चन. अब देखो क्वेश्चन में क्या है. A body at temperature 50 degree cools to 49 degree in time delta T. So 50 is the temperature T1, let's say, and later on it is becoming 49 degree. Let's say T2. So dt is how much? dt is your 1 degree, right? Minus 1 degree आप लिखोगे, मॉडुलस में लिख रही हूँ. So this is 1 degree. Now it is placed at room temperature minus 3 degree. So T naught is equal to how much? Minus 3 degree. Okay. Let us see here the same, and this cooling is happening in how much time? Delta T. So अगर आप expression में use करना चाहते हो dt by dt minus of this equal to k delta T, और that is k dt or kt, right? Sorry, यहाँ पे dt already है, क्या कर रही हूँ मैं? So this is your what? K, this constant k basically. So minus dt को आप क्या लिखोगे? K dt. Okay. So let us write the value of dt. So let us write the modulus. Negative sign we will remove. So this is 1 and this is, okay, something is missing I guess. Here there was delta t, right? Sorry. So here there was delta t. Okay. I felt like there is something missing. So this is this, right? सबसे पहले आप dt लिखो. dt is how much? That is 1 degree. Modulus मैंने लिख दिया. Time delta t time it has taken to cool from 50 to 49, right? K constant we don't know. Delta T will be what? This is the temperature of that body, temperature difference of that body with the surrounding, right? So this is 50 also, 49 also. Take the average of these two. So that will become how much? 49.5. And then you will be doing here 49.5 minus of this minus 3 degree. So plus 3, right? Let's say this constant is K1. Now for the second case, what is the thing? The same body cools from 50 to 49 in time delta T dash when placed in a room that is maintained at 24 degree. Now T naught is changing and so K will change. Always remember this K is function of temperature, right? And this K is directly proportional to T naught ka cube, if you remember, right? So except that everything is constant. Then a same body हम use कर रहे हैं. So S will be same, surface area will be same, mass will be same, everything is same except the room temperature. So here it is K1. Second case के लिए अगर आप लिखते हो, then in second case, I mean temperature change is happening from where to where? 50 to 49. So second case में अगर आप check करो, it is going from 50 to 49. So again dt is same, modulus wise, that is 1 degree, right? And what will be this delta T? Delta T, take the average of these two temperature, 49.5. So 49.5 minus 24, right? And this will give you how much? 25.5, right? So second case के लिए अगर आप लिखते हो delta T dash you will be writing and this will become K2 and here it will be become 49.5 minus 24. This is the thing. Now we can calculate what? Delta T dash. सो एक काम करो आप 1 बाई डेल्टा टी दोनों ही टर्म को आप डिवाइड कर लो, ठीक है? इनको अगर आप डिवाइड करोगे व्हाट यू विल बी गेटिंग? डेल्टा टी डैश बाई डेल्टा टी इज इक्वल टू व्हाट इज दिस? दिस इज K1 बाई K2 ठीक है। सो K1 को आप क्या लिख लो, K इंटू टी नॉट, दैट वॉज राइट। सो टी नॉट का पावर Q डिवाइडेड बाई K इंटू टी नॉट डैश का पावर Q, and this is how much, 49.5 plus 3, so this is your 52.5, right? So this is 52.5 divided by 25.5. So this is this one, right? Now you just put the values. K constant hoga kyunki rest things were same, right? Same body we were taking at two different room temperatures. So this has changed. Now let us put the value of T naught. T naught आप क्या रखोगे? First case में क्या था? -3 डिग्री. And I have told you in Stefan's law, temperature को हम कैसे लिखते हैं? Kelvin में लिखते हैं. And this T naught was in Kelvin, right? हमने अभी derivation इसीलिए किया. This was in Kelvin क्योंकि हमने स्टीफेंस लॉ के हेल्प से ही इक्वेशन डिराइव किया है ना. सो टेम्परेचर always in Kelvin. T naught was how much? -3 degree. So this will become how much? 270, right? And this is 24. So 273 plus 24, 297 you will be getting. So 297. And this is Q. And this into 52.5 by 25.5. So this is your how much? This is delta T dash by delta T. ठीक है. अब आप देखो इसका आप एक काम करो, वैल्यूज निकालो. सो लेट मी डू दैट. आई मीन आई विल बी टेकिंग द हेल्प ऑफ कैलकुलेटर, है ना. बट तुम्हें नहीं लेना है, ठीक है. तुम्हें खुद से हेल्प करनी है, सॉरी सॉल्व करनी है. सो 297 बाई 2 this 273, it will become almost 1.33. So यहाँ पे एक काम करो, this will become 1.33 into 52.5 by 25.5. If you solve it, you will be getting almost 1.55. ठीक है. So delta T dash तुम्हारा क्या आने वाला है? 1.55 delta T. This is what we have got. So Newton's law of cooling ka constant thing, from where it is coming, how to write it, on what factors it will depend, it is important. Okay. I hope you have got this concept, but if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.